All right, so hello everyone, and welcome back to the channel. The other day I was working on some Expo router tabs, which as you can see, do the navigating as you would expect from custom headless Expo router tabs. They work quite nicely. But I thought, wouldn't it be cool if we could make them liquid, just like this? How fun is that, guys? So today what we're going to do as a project is we're going to make these nice liquid tabs using React Native Skia and Expo router as well. I think this will be a lot of fun, guys. So in the description, you will find the starter project as the main branch, and then you'll find the final code in the solution branch if you like. So yeah, without any further ado, let's get started and talk about the conceptual overview behind how to make all this stuff. All right, guys. So before we get started, I wanted to quickly talk about shaders because that's what we're going to be using today in order to build out those nice liquid tabs that you saw. I wanted to give a conceptual overview first, because if you've never worked with shaders before, this is going to be all kinds of confusing, and it helps to have like a good idea of how they work on a high level first before you get into coding them. So there's a few different categories of shaders that are really popular. There are, for example, noise shaders. There are gradients. Gradients are probably the best example because we've seen a lot of linear gradients before if you've done React Native for any period of time. And the last type are SDF shaders. Of course, there's probably many other categories. This is just the categories that I'm using today in order to keep things simple. So what is an SDF shader, right? And why do we use it today? So an SDF is an acronym, and it means signed distance function. And what this means is that every shape that we make using our shader canvas is going to be built using a specific mathematical function that creates the shape for us. But in this case, though, before we can even get into the sort of mathematics of the whole thing, we should first talk about how shaders work in general. So when you have a shader, every single pixel has a function that's run on every single frame. So if we have a phone that looks something like this, and I had gigantic pixels like this, I'm making them giant just so it's easy to see. Every individual pixel here runs its own copy of the function at the exact same time. And the only parameter that these functions get is their XY location inside the actual canvas. So that's all they know. Every pixel is independent of every other pixel. So none of them have context on each other. All they know is where they are on the canvas. And to most people, this would seem strange. Why wouldn't you expose state to everything? The reason that we do this is because in shaders, you can take full advantage of the hardware on the GPU. And because every pixel is running a function at the exact same time, that means the GPU can use more of its resources in order to allocate them to every individual pixel. So I think there's a good resource out there called the Book of Shaders, and it describes it like a printing press. So basically, the GPU on every screen runs its function for every single pixel, and at the same time, it assigns to each pixel the color value that that pixel should have. Now that we know how the shaders work and what sign distance functions are, let's talk about the actual canvas and how the shader canvas is going to work. So canvases are a little different. When you think about shaders, of course, we have the usual like XY paradigm that everyone's familiar with. But where things get a little bit strange is that X and Y don't have density independent pixels like we're used to when we operate in React Native. So if I'm on like say an iPhone 16 versus an iPhone 14 versus an iPhone 10 or something like that, this X value could be like 1,000, it could be 120, it could be 1,400. I really have no idea. Same thing goes for Y. I could have any amount of pixels. I have no idea how many pixels I'm going to have ahead of time. And so we need some way to make these things independent of the device that you're using. And the way that we do this is by normalizing the canvas. I'll show you how to do this in code a little bit later on. But basically what you do is you take the canvas and you kind of cut it in half on the x-axis and on the y-axis. So this spot becomes 0. This becomes -1. And this here becomes 1, basically. And then at the extremes, again, you have 1 just over here. as well, and this is also 0. So you have this pattern of -1, 0, 1, 1, 0, sorry, -1, 0, and 1 at the end. And so when we draw our shapes, we express our shapes in percentages from 0 to 1. So if you wanted to be halfway between 0 and 1, this point would be represented as 0.5, 0.5, and not expressed as the number of pixels that we have. So let's talk now about the actual function that we use for a circle and how that works within this paradigm that we have. So in our canvas, with our x and our y and our -1, 0, 1, -1, 0, 1, what we end up doing is starting our circle from the middle, just like this, and we decide on a radius for our circle. So let's say the radius for our circle here is going to be 0.4. And that's going to be the length of from the middle to whatever other points are going to be around this. And then what it does is it calculates the Euclidean distance between these two. And if you are inside of the circle itself, the Euclidean distance is going to be negative. So it'll be somewhere around like -1. Whereas if you're outside of it, you're going to be a value of 1 or above. So anything with a value of -1 or less, we color it in. And anything with a value of +1 or more, we don't color it in. And you'll see this in code in a little more precision later. But basically, that's all you need to understand the high level of what we're doing today. Let's get into the code. All right, guys. So before we get started, I wanted to really quickly go over the boilerplate that I have here. I wanted to make some boilerplate just so that I could get the tedious stuff out of the way and that we could focus on the actual animation that we're working on. So as you can see, I have some really basic tabs going here with Expo Router. None of this does anything particularly special or particularly interesting, just some basic tabs. Beyond that, I have some constants for dimensions and easings. For the most part, these values came from trial and erroring, so I didn't want to waste your time with showing all of that. Finally, the last piece of boilerplate that I have for us today is this context provider, and it's going to be used to share the state between the Skia animation and the router tabs because they're separate and they need to be able to share some state. But I'll give you some more information on that when we get there. Okay, so now that we're acquainted with the boilerplate, the first thing that we're going to do is we're actually just going to remove these tabs and replace them with the Expo Router UI tabs, because those tabs will give us the ability to customize things and sort of make them more our own. So first we're going to make this Expo Router UI, and I'm going to grab tab list. I'm going to grab tab slot, and I'm going to grab tab trigger. From there, then back inside of here, I'm going to borrow this icon, but really I'm going to remove basically all this because a little bit later on, I'm going to bring it all back. So let's keep this one commented for now, just so I can remember what all the stuff was. But for now, we can just kind of forget that it's there, and we can delete the old screen options. All right, so under here, the first thing that I need is a tab slot. I'm going to wrap this with a couple views that I'm going to use for styling. The first one's going to have flex 1, so it fills everything. And then the second one is going to have a flex 1 and a background color of white. And then inside here, I'm going to put my tab slot. So now, outside of my tab slot, I'm going to start working on my tab list. And then my tab list is going to have a little bit of light styling on it. So I want it to have a padding bottom. This will keep it away from the safe area insets at the bottom. So I'm going to also need those. And so I'm going to say insets dot bottom plus 80 to give a little extra space for our tab bar. I'm going to make its background color white. And then finally, I'm going to justify content flex start. And that should take care of our tab list. I have a view here. I'm going to fill that in a minute with our Skia animation. But before we can do that, I first need at least one tab trigger in order for things to compile. So I'm going to add that now. Its name is going to be home. And its href is just going to take us back to, obviously, home. And then inside here, I'm just going to throw an icon for now. It's going to look terrible, but I just kind of want things to compile. So here's what it ends up looking like. We have a tab bar with basically nothing in it. And actually, I don't even need the icon. I'm going to remove that for now. All right, guys. So at this point, as you've just seen, we created the tab triggers and the tabs. And the way that things are going to work, kind of like I said earlier, are that the tab triggers are going to be the tap targets that you're going to touch with your finger. But the Skia animation is actually going to be a backdrop. So it's going to create kind of the illusion of buttons, but the actual buttons themselves are on the tab trigger. So Skia is the UI, tab trigger is the actual pressable part. So in order to make this a backdrop, we're going to need to absolute position these buttons. And we're going to get them to fill the space. So we're going to have a top, bottom, left, and right of 0. And inside here, I'm going to add my liquid navigator. Right now, this component is totally empty and has nothing inside. And I'm going to grab the state from use liquid nav. And I'm going to cast this to state, or rename it to state. I apologize. All right, and at this point, everything's connected up. You still won't see anything, but at this point, we can go into the Skia part and actually hopefully see things working. So now that we have all that sort of boilerplate set up, let's go into the liquid navigator and start building it up, because right now it does absolutely nothing. So we're going to make an interface props, and props is just going to take in a state. That state is going to be the navigator state. At this point, I'm just going to do something really, really simple. We're not going to do any shaders or stuff just yet because we want to make sure everything kind of renders the way we expect. So I'm going to use a view here and style it so that its height is the height of the canvas height, and then its width is 100% of its parent. I'm then going to do the same with a canvas just inside of it. So I'll just copy paste these styles and import it. So it looks like I didn't install React Native Skia. Let me quickly do a yarn install of that, and I'll be right back. Okay, so I just finished installing. All you had to do is run this command really quickly, and you'll get Skia and reanimated, which we'll need for basically the rest of this project. But back to what we were doing. I just want something to show up just to prove that the backdrop is working. So I'm going to make a rectangle and put start position at the top left-hand corner. Of course, I have to import that from Skia as well. And then I'm going to make the height equal to the canvas height, and the width is going to be equal to the canvas width. Actually, I think I can just do, let me look at my constants, screen width, because it's always going to be the screen width. And then I'm going to color this in, and I'm going to make its color purple, just so that we can get something on the screen. And as you can see, at this point, we now have this purple thing here, and we can start filling this in, this being our space for the tab bar with our shader. So now that everything's hooked up, let's get started on building the shader. To do this, I'm going to first just remove the color because the shader is going to provide the color. We're not going to get the color from anything else. And to make a shader in Skia, we have to import the Skia tools. And we're going to use Skia runtime effect make. And we're going to put our shader inside of this string here. So inside of the rectangle, I'm going to then give it the source, which is the shader. And I'll save the uniforms for a little bit later. I also noticed I set the props wrong, so I'm going to quickly fix that type. So for the shaders, I'm going to first grab some constants here that we're going to end up needing as we go along. The SDF circle and this S minimum come from Inigo Quiles' blog. He is an extremely talented shader artist, and I'm going to put a link to his blog and where I found all of these 2D shapes and stuff in the description so that you can review it later and you can use that source to create all kinds of other cool and original things. But in the shader, like I said, it's a little program, and it's a program that takes in a function with the coordinates of your pixel. That is, of course, this vec2 position, a vec being a vector. So this is a 2D vector. This is a 4D. In the 2D vector, the values are x and y. In the 4D vector, the values are R, G, B, and A. So red, green, blue, and then the alpha. For now, I'm just going to return like the simplest possible thing we can do, which is a rose color with opacity 1. All right, and there we go. Now that we have our color here and we have our really basic setup, the next thing that we're going to do is we will take this main function and we're going to normalize the coordinates to be the normalized canvas that you saw at the beginning of this video if you remember that whiteboarding session. So in order to normalize our coordinates, we're going to make a variable called UV, and we're going to divide our position by the aspect ratio. And right now, this variable, of course, doesn't exist here, so I'm going to create it. The data type of this value is called uniform. A uniform is a value that's passed in from outside the shader into the shader, and I'll show you how to do that from React Native in just a minute. But in the meantime, let's finish normalizing our stuff. So we're going to subtract from both the x and y part of the vector 0.5. And in the x part of our canvas, we are going to multiply by the aspect ratio dot x divided by the aspect ratio values dot y. And that should correct everything the way we need it. Next, I'm going to create a method called drawScene. And the only reason I have this is because I want to keep my logic for actually drawing and for normalizing the canvas separate. And so that's why this exists. There's no other reason you have to do this. I just kind of prefer to do it this way. So in drawScene, we're going to have this vec4 called column. And for now, I'm just going to give it a value of 0. And in the end, what we're going to do is we are actually going to basically just build this up as we go through, and this call is going to slowly become something more and more complex. So last thing we need is those uniforms, and like I said, we have to pass them in from React Native. And these are just a derived value because we're going to want to animate them later. And the uniform that we're going to use is the aspect ratio, and the aspect ratio is going to be our two height and width values. So it's going to be screen width and the canvas height. And that should give us everything we need. And now we pass these uniforms into here like that. And it looks like I forgot a semicolon somewhere. I forgot it right here. And as you can see, this is now white. If in column I change this to say like rows and 1, you would get the pink back. All right, guys, so let's draw our first shape here. Now that we have all the boilerplate set up, let's make a circle 1. And that's going to be equal to this SD circle method. And in here, we're going to pass in our coordinates. We're going to pass in the value of 0.5, and then I'm going to pass in a 2D vector of 0 and 0. So of course, the UV is the value of our canvas. The offset is how far you want to push it to the left or the right. And the radius is how big, of course, the actual circle is going to be. It's all just like we described in the beginning, works exactly that way. And also, just like I said in that first whiteboarding session, we are going to calculate whether a given point in the circle is greater than 0. If it is greater than 0, we are going to give it the color of 1, because we don't want it to really have any color whatsoever. Otherwise, we're going to give it a color that actually does make sense. So RGB, this is going to be mostly blue shape, and actually it should be one dot the other way around. So this is going to be a blue shape with an opacity of 1, and we should see a blue circle somewhere around the middle here. And of course, I forgot to say it was a vec4, but as you can see, once I do that, we now have a circle in the middle. So obviously, guys, we're going to want to draw more than one circle at any given time. And we actually want 3 to be here and to be equally spaced. So in order to do that, we have to do all the calculations ourselves. The reason is because not only are we in Skia, we're also not in the Flex world anymore. So any calculations for spacing, we have to do those all on our own. So the first thing we're going to do is have some padding here. And this padding value is how far we want everything shifted in from the left and the right-hand side. We also need the screen width, which we can determine from the aspect ratio values that we have. So we're going to use the aspect ratio x divided by the u aspect ratio dot y. After that, I need the total width, which is going to be the screen width minus the padding on the left and the right that we want to impose here, which is nice. Finally, I'm going to need the spacing as well. That's going to act as the spacing between the circles. And that's going to be equal to the total width divided by 3.2. This 3.2 is just a magic number I came up with that looks like a good spacing. Feel free to make that whatever you want. Finally, I need to know where to start on the x-axis, and that's going to be the negative spacing. So basically, it's going to be negative 1.5 is going to be here, 0 is here, and then 1.5 is going to be the one on the right, just like that. Okay, so at this point, I need to calculate the boundaries for the positioning. So I'm going to say the half padding is going to be equal to the padding times 0.5 float. After that, the left boundary is going to be the negative screen width multiplied by 0.5 plus the half padding. And then the right boundary is going to be just the opposite of this, minus, and then this value is positive. So I'm going to calculate the offsets now, and the circle radius. I'm going to put zeros in certain places for now. The reason that I'm using zeros is because I'm going to make those values dynamic a little later on, but I'm using 0 for now just because these values aren't dynamic yet and I need a placeholder. So the offset of the leftmost item is going to be 0 multiplied by the spacing multiplied by 2. The center offset is going to be equal to 0 multiplied by the spacing. And the circle radius, which also will have to be dynamic, is going to be 0.5 minus 0. And again, all these 0 values are going to be dynamic in the near future. But for now, I'm just keeping the 0 here as a placeholder. Okay, so now that we know all the different offsets for all of our different circles, let's actually create the circles. So first we can reuse our circle 1. So for our circle 1, we keep the UV, we keep the size 0.5, but for the position on the vec2, we're going to use the start x value, and then we're going to add the left offset to this. So that should shift it over. Oh, I put the bracket in the wrong spot. Okay, so we're going to have circle 2. Circle 2 is going to have the exact same sizing, but it's going to have start x, and then it's going to have the spacing added to this, plus 0 for now. This is another placeholder. And then we're going to have circle 3, and that's going to be the same thing, but start x is going to have the spacing multiplied by 2, and plus 0 again, because that's another placeholder. So now, separately, obviously, if I use our little if statement here, you'll see these circles kind of move across the screen like that. And I sort of need a way to combine these together. The way that you do this is through a minimum function. So I'm going to call this meta balls. And I'm going to use this smooth minimum function from above called smin. And I'm going to combine circle 1 with circle 2. Then after that, I'm going to combine the meta balls with circle 3. And that should pull everything together for us. Oh, and of course, I forgot the k value in both cases, and the k value is 0.5. All right, so instead of circle 1, I put the meta balls in here. Now, the cool trait about this is that if I start moving these to the side, which I can probably do with this one, so this one's like something like this right now, you can see that the meta ball effect is here, which is super cool. So guys, if you didn't want the meta ball effect, it's pretty easy. You would just change this to be the minimum function, and this would just move them. But it's the smooth minimum that gives us this nice sticky meta ball sort of effect, which is really, really cool. So now that we have that hooked up, I just quickly hacked a button into the home screen, guys. All the button does is flip the state from 3 to floating action button. It literally does nothing more complex than that. I just wanted to really quickly do that so we had a way to start the animation because we don't really have a way of navigating just yet. Anyways, what we're going to do now is we're going to actually pass the animations into our shader so that we can start moving these circles around, which is really interesting. So we're going to need shared values for this. And the first of these is going to be the navigator state. And actually, we're going to default that to center. And then we're going to need some shared values. The collapse amount, we're just going to start at 0 because all of our defaults were 0, as you guys just saw when we made the shader. It's also going to be 0. And then finally, we're going to have the right anchor offset. And that's also going to be 0. Now, every time that this prop changes, we're going to use the use effect to update that value. And what we're going to do is we're going to say the navigator state value is going to be equal to the state. Finally, we're going to have a use animated reaction. And this is going to return the navigator state.value. And then after that, it's going to take in that value. And then it's going to do the actual animations and stuff like that. So we're going to say if the value is equal to 3, we're going to do one thing. Otherwise, we're going to run some different animations. So when we're at 3, we're going to say the collapse amount value is going to be equal to a timing. And that timing is going to go down to 0 because we're animating back to the beginning, right? The duration is going to be the liquid speed. And the easing is going to be our, what did I name it in the constants? The liquid easing. And then I'm going to just copy paste this a couple times. And we're going to use that for the shrink amount and also for the right anchor offset. Similarly, for when we are not in the 3 mode, but we're in the floating action button mode. So maybe I can make this a little clearer. I can say value is the fab. If that's the case, we are going to animate out, and then the collapse amount is going to have a value of 1. The shrink amount is going to have a value of 0.21, and then the anchor offset is also going to have a value of 0.21. So floating action button moves to 0 because 0 puts everything where it is now, and the floating action button has these different values because it's going to animate them towards the middle. In order to do this though, of course, as you may have guessed, we need some more uniforms. So I'm going to make a few more. So we're going to say uniform float u collapse amount. And then we need u shrink amount. And then we need u right anchor offset. Now that we have all these values, we need to actually apply them. So I'm going to find all the places where I put those little 0 placeholders. So for the left offset, I need the collapse amount. For the center offset, I also need the collapse amount. For the circle radius, I need the shrink amount. And now, there's a few more places I need this. So the left offset, spacing plus 0 should be spacing plus the center offset, which I should have done, right? Center offset, oh, sorry, center offset up here, I'm sorry. So yes, I have the center offset. And for this one, I need the u right anchor offset. I think that should take care of everything. Of course, I mistyped float. And it's going to crash because I did not pass any of these uniforms in. So let's pass those in now. I'm going to copy this so I remember all the names. So the collapse amount is going to be equal to the collapse amount value. The shrink amount is going to be equal to the shrink amount value. And the right anchor offset is going to be equal to the right anchor offset value. And it should just be that simple. So I got to reload. Oh, and if I click animate, as you can see, it started animating in and out. But the problem is that my radius is not shrinking. So I got to figure out why my radius isn't shrinking as we go. The reason the radius isn't shrinking properly is because I have to replace the 0.5 with the circle radius. So now if we do this again, I probably need to reload. Let me reload. If I do this again, we can see that everything animates really nicely in and out. We're almost there, guys. Okay, guys, so let's finish off by coloring these in. Of course, we still have the last step, which is actually navigating, but this is the last step before we start navigating. So if you remember from the beginning, we had that nice thin gradient border. And in order to have that, we'll start by defining a very small border width. We're then going to use a shape mask and compare where we are in the actual shape in order to decide whether or not we apply a gradient or not. We're probably pretty used to if statements from normal JavaScript logic, but step here is basically just a mathematical function that does a very similar comparison, but using numbers instead. So I'm going to pass in our metaballs and compare to 0.0. After that, I'm going to create an inner mask. This time, we're going to do the step with the metaballs, but we are going to pass in the negative border width. So that'll give us the mask that we need in order to make the final comparison. We're then going to be able to check if it's an outline by subtracting the shape mask from the inner mask. And in order to get that like gradient kind of effect on the border, we need the normalized y, which is uv.y minus 0.5 to kind of give us the top, sorry, plus 5. And then after that, what we're going to do is we're going to create an outline color. And that color, is going to be mix And mix, by the way, is a function that basically linear interpolates from 0 to 1. So this mix function is effectively creating the gradient. So we are going to mix from the purple color to the pink color. So it's going to interpolate from purple to pink. And then it's going to use the normalized y in order to do that. Finally, the final color with everything in it is going to be our rose color multiplied by the inner mask plus the outer color, the outline color multiplied by is outline. Finally, our alpha value is going to be equal to the shape mask. So we should be able to just put these values together in the column. So that should be vec4 is equal to the final color and the alpha. And hopefully that'll just work. Let's see. Oh, and as you can see, we got it first try here. And everything animates really nicely, including the gradient, which is really cool. All right, guys, we're ready to move on to the actual navigation piece. So now that these buttons are done, let's go back into our tab layout and let's actually build this out. What we're going to have to do here is we're going to have to position the tab targets on top of each of the buttons. And I'm going to just paste this. We're going to start by basically doing the same math that we did in the shader, but bringing it outside of the shader so that we can have the same exact type of positioning here. So what we're going to do here now is we're going to calculate the starting points of all these buttons. And our left button X start value is going to be equal to the start X value plus half of the screen width. And this is the screen width as determined by the aspect ratio up here. After that, I'm going to divide that by the screen width and multiply by the full width, which is the, let me move this out of the way here, which is the screen width as the hard-coded value. After that, I need to calculate the center button starting X value. And this is going to be the start X plus the spacing now, and half of the screen width, plus. And then after this, it's pretty much the same as the last one. You divide, then you multiply just like that. And then finally the last one, it also follows this pattern. So actually I'm probably just going to copy paste and just update this. So we're going to have the right button X, it's going to have the start X, it's going to have the spacing. This time I'm going to multiply the spacing by the spacing multiplier constant that I have. So you're going to have start X plus the spacing times the screen multiplier plus half of the screen width. And then this part obviously is the same just on all of these now. All right, so at this point, I'm going to calculate how much I need to shift the metaballs as they go through. And that's going to be the metaball shift normalized constant I have divided by the screen width as determined by the aspect ratio multiplied by the canvas width. Sorry, the screen width, like the real screen width. And then the floating action buttons, center X, is going to be equal to the start value of X plus the spacing multiplied by the spacing multiplier plus the floating action button shrink amount plus half of the screen width as determined by the aspect ratio divided by the screen width multiplied by the canvas width. Oops, sorry, the screen width. Okay, so this should give us all the values that we need in order to position the different views that we have available to us. So what we're going to do is I'm going to take this tab trigger here, and inside here I'm going to add an animated view and import that from React Native Reanimated. And I'm going to grab this icon here. I may have to fix the import actually, so let me quickly do that. So the import is here for and icons. And I have to close the tag for animated view. Whoops. And these here are just some constants that I have to import. And that should give us an icon. So now I have to actually position this. And in order to position it, I first kind of need a style for the button. So I'm going to create that. And I have to import style sheet from React Native. Okay, so inside here, I need my button style. And the button's going to be absolute positioned because, of course, I have to be able to have canvas style sort of positioning so that I can place a tap target perfectly on top of a button. The width is going to be the button size. The height is going to be my constant for button size. I'm going to justify the content as center and align the contents as center, so nothing super special here. And then the top value is going to be the center Y we calculated above minus the button center offset. So let's apply this style now. And we're going to need a few styles, so I'm going to put this in an array. But for now, we're styles.button. After that, what I'm going to need is I'm going to need to say from the left, I want it to be the left button X spacing minus the button center offset. And I'll save. And let's see where we are so far. So as you can see, we're really close, but we just have to kind of push it over a little bit. Let me take a look into why this is slightly off. Oh, and I see it. The reason is because this should be align items, not align content. And that one's nicely centered. So now that we have that working, we can just take this tab trigger and copy paste it. And I'll make this path explore. And then its icon is going to be a person. And for this one, its path is going to be edit. And then I want this icon to be search. And actually, I'm going to switch these ones around. I actually want this one to be up here. And now to position them, we just use the positions from above, the right and the center. And now everything's laid out exactly the way we want to. All we have to do now is just to add the floating add button thing. And this is going to look a little weird at first, admittedly, but I promise we will fix it and make it nicer. So this is going to be add. And then its position is going to be the floating action button center minus the meta ball shift in pixels minus the button center offset. And then for the icon, we are going to use the add icon. And so another thing that I'm going to need is a little bit of styling because it's styled just slightly different than the other ones are. This is not going to be button style. This is going to be floating action button container style. And so its position is going to be absolute, just like everything else, because we need that canvas style control. And the top is also going to be the same as everyone else, the center Y minus the center button offset. And then inside the button itself, its width and height are going to be the button size, just like the normal button. But the difference here is that we're just going to justify and align the content center. We don't need to do anything else here. So to do that, I'm going to make the style of the add button the floating action button container. And I'm going to wrap the icon with a view. And then the style of that view is going to be the floating action button. And it looks a little weird now over here, but I promise you once we have the animations, it's all going to look a lot nicer. The last thing that we're going to need to do here is actually put the animations all together. And we're going to do that by sort of fading them in and fading them out as the meta balls move around. So the way to do that is we're going to need to have the navigator state be in a shared value because we're going to use that to animate pretty soon. We're going to need a shared value to control the 3 buttons as well and what their opacity is going to be at any given time. and we're going to default that to 1, and the floating action button opacity is going to default to 0. I'm also going to have a use effect here just to make sure that no matter what happens, they initialize at the correct values. Finally, I'm going to have a use effect here. And basically what it's going to do is when the navigator state value is updated, the state value is updated, we're going to update it to the navigator state. And that should keep those two in sync. So finally, now that we have all this boilerplate together, we're going to make a use animated reaction. And in here, we are going to do the actual animations. So we're going to say navigator state.value. And then the value is going to be returned here. And then inside of this function, we're going to have an if statement. So if the value is equal to 3, we're going to do something. Else if the value is equal to floating action button, we're going to do something slightly different. And so what we're going to do here is we're going to say the floating action button opacity value is going to be equal to a with timing. And in the with timing, we're going to go from 1 to 0. So this is transferring it to the 3 buttons being visible. The duration of this is going to be our liquid speed that we defined earlier, multiplied by the fade duration multiplier. And then the easing is going to be a easing in. And I'm going to use easing.ease for that. I'm going to copy paste this because we're going to do something very similar with the 3 buttons opacity. It's basically almost the same thing, but in the opposite direction. So we're going to do a with delay. And then the delay is going to be the liquid speed multiplied by the opacity interaction multiplier. And I'm going to move this out of the way. And then I'm going to, I think I might have imported the wrong easing. Yeah, I did. Easing's got to come from here. Okay, so now I'm going to copy paste these down into here. And instead of the floating action button, I'm going to have this be the 3 buttons opacity, and that's going to be the floating action button opacity. So they're going to kind of flip. And now the last thing I need to do is just add some simple styles here. And I'm just going to copy paste these because they're pretty easy to write. Basically, all I'm doing is I'm injecting the floating action button opacity or the 3 buttons opacity into an animated style. And I'm turning off pointer events in that particular button if the opacity is 0 or 1 respectively. So for the 3 button style now, I just have to add it to these. And then finally, for the floating action button container, I use the floating action button style as my additional style. All right, so now if I try this out, hopefully everything works as okay, and I can see this is slightly off, but the reason is because when I copy pasted, I forgot to make these opacities 1. So let's restart the app. And now if we click, as you guys can see, we have the really beautiful tabs all working perfectly. Thanks for watching, guys. And as always, happy hacking.